Ever wondered what data engineering actually is? Or seen the data engineer role and felt confused? This video will make it clear. I will break it down step by step using real world examples. Now let's get started. Here is what we will cover today. We will start with why data engineering exists and what it actually is. Then walk through a simple real world data pipeline. After that, we will look at what a data engineer does day to day, the skills required for the role, and finally, where this role fits in a data team. So let's start with why data engineering even exists. Every company today generates data everywhere, from mobile apps, websites, payment systems, and system logs. But the problem isn't the lack of data. The problem is that this data lives in many different places. Let's understand this with a simple example. Imagine a company that wants to analyze its sales data. Now, this sales data doesn't come from just one source. Means some sales data is stored in a database from the payment system. Some data comes from website, things like user clicks and orders. Some data might be in Excel files shared by the operations or the finance team. And some data comes as a raw JSON events or logs from different systems. So even though all of this is a sales data, it's spread across different systems in different formats and at different levels of quality. In this form, this data is messy and you can't directly answer the questions like how much did we sell yesterday or which product is performing best. That's because the data is scattered. One file might contain sales information and another contain product details and another might have the payment data. To answer the simple business question, this data first needs to be combined and cleaned. And this is where data engineering comes in. So, a data engineer takes all of the scattered raw data, cleans it, standardizes it, combines it, and finally stores it as a clean structured tables so that the analytics and the business teams can actually use it. This exact problem of turning the scattered raw data into a reliable, usable format which the analytics or the business teams can use is why data engineering exists. Now that we have seen why data engineering exists, let's talk about what data engineering actually is. In simple terms, data engineering is about building systems that collect, clean, and organize raw data so that the data can be used for analytics and decision making. At a high level, you can think of data engineering in three stages. First, we collect the data from different sources. Then, we transform it, which means cleaning the data, fixing the inconsistencies. And finally, we organize that data into structured and reliable tables. Once the data reaches this stage, other teams can actually trust it and use it for the analytical purposes. Now, let's bring everything together with a simple real world example. Imagine a company wants to understand its sales performance. The problem here is sales data doesn't come from just one place. Some data comes from databases, some comes from Excel files, and some comes from JSON logs generated by the applications. All of this data is raw, scattered, and inconsistent, which makes it harder to use it directly. So, the first step in a data pipeline is to bring all of this data into a central storage layer. This step is often called as data ingestion. Depending on the company, this storage layer could be a data warehouse or a data lake or something similar. But the main idea here is simple. Instead of data being scattered across everywhere, we store it into one place. And once the data is stored, the next step is to clean and transform it. And this is where we fix data issues like missing values, duplicates, or incorrect formats. We also apply business logics at this stage. For example, calculating the total revenue, standardizing the product's name, and so on. You might hear terms like ETL or ELT used here. And these terms describe when the transformation happens. Like the transformation happens before or after the data has been stored. Don't worry, we will go deeper into those concepts later. So finally, the data has been cleaned and organized after the transformation layer, and now this data can be used to build reports and dashboards. And analytics or business teams can actually rely on this. So at this stage, teams can trust the data, use it to answer their business questions. So this is the high level view of a data pipeline. And when we go deeper, each of the stages uses different tools and technologies. But the flow from the raw data to storage to transformation and analytics is the foundation of data engineering. Now, let's look at what a data engineer does on a day-to-day basis. A big part of the job starts with understanding the data requirements. That means talking to different teams and understanding what data is needed, what questions they want to answer, and why that data matters. Next comes building and maintaining data pipelines. This involves moving the data from different sources into a central system, transforming the data, and making sure those pipelines run reliably. A data engineer also spends a lot of time in cleaning and transforming data. This is where a raw, messy data is turned into a structured and meaningful data. Another critical part of the role is ensuring the data quality and integrity. That means checking for the data issues, fixing the broken data, and making sure people can trust the numbers that they see. This is what a data engineer typically works on day to day at a high level. As you go deeper, this role can involve more advanced work like orchestrating the pipelines, optimizing the performance, and working with complex systems at scale. But these fundamentals are the core of the data engineering role. Now, let's talk about the skills a data engineer needs. I have divided the skills into sections to make them easier to understand. The first section is core skills. These are the skills you should focus on as a beginner, and these are non-negotiable. The most important one is SQL. SQL is used every day in data engineering. It's the primary way we work with data stored in tables. Next is Python. Python is commonly used for automation, data processing, and building the parts of a data pipeline. Then comes data modeling. This is about how the data is structured, things like facts, dimensions, and relationships. You will often hear terms like star schema, snowflake schema here. Along with this, you need a basic understanding of data pipelines and its overall architecture. You should also have some basic knowledge of at least one cloud platform, maybe AWS or Azure or GCP. And you should know how to work with at least one data warehouse. It could be Snowflake, Redshift, or BigQuery. If you remember just three things from the slide like SQL, Python, and data modeling, these are the skills most commonly tested in interviews. And they form the foundation that every data engineer needs. Once your core skills are solid, the next set of skills you will pick up are workflow and platform skills. These skills help you work in real production data systems where multiple pipelines run every day. The first one is data transformation. It is commonly done using tools like DBT. And this is where the raw data is cleaned and shaped into tables that actually make sense for the business. Next comes orchestration, which is done using tools like Airflow or Daxter. So, as the system grows, you don't run one pipeline, you run many pipelines. So, orchestration is about managing when pipeline runs, the order in which steps run, and what happens when something fails. Then there's version control and CI/CD. In real teams, data pipelines are built and maintained by multiple people. So version control helps team to review the changes, work together safely, and avoid breaking the existing data pipeline. And finally, some understanding of Linux and working with systems. So this helps you debug issues, run jobs, and understand what's happening behind the scenes. So these skills sit on top of the core skills. This is where data engineering moves from learning concepts to building real systems in production. The last set of skills I want to talk about comes into play when you are working with big data or real-time systems. You will often see this mentioned in the job descriptions because many companies deal with very large data sets or need data to be processed quickly. The first one is Spark, often used through platforms like Databricks. Spark is the distributed processing framework, which means it can process large amounts of data by spreading the work across multiple machines. This is why Spark is in high demand today. It helps companies handle data that is too big for the traditional systems to process efficiently. The second one is Kafka, which is used for real-time data streaming. This comes into play when data needs to be processed as the event happens instead of waiting of the bad jobs to get completed. For example, when an order is placed, the dashboard updates immediately or the operations team is notified in the real time. That's what real-time streaming means. Like changes in data are reflected almost instantly. So whether you use Kafka or Spark, that depends on the company's data size and architecture. Some data engineering roles use these tools heavily and others rarely use it. And both are completely valid data engineering roles. These skills you typically pick up after your fundamentals are strong. So once your core skills are in place, you can build on top of them with tools like Spark or Kafka as needed. The key is to focus on the fundamental first, which are SQL, Python, data modeling, and then add the skills when the use case demands it. Now let's understand where the data engineer role fits in a data team. A simple way to think about a data team is as a flow. On one side you have data sources, things like application databases, logs and external systems. The data engineer sits right in the middle of this flow, and their responsibility is to take data from these sources, clean it up, organize it and make sure it's reliable. Once the data is ready, it is used by the data consumers like analytics engineer, data analyst, data scientist, and these teams focus on analyzing the data, building dashboards, generating insights, and finally, those insights are used by businesses and product teams to make the decisions. So, the data engineer acts as the foundation of the data team. When data engineering is done well, everything else becomes easier. And when it's not, every team downstream feels the impact. Remember, data engineering is a journey. You start with the basics and you grow step by step. You don't need to learn everything at once. Just focus on building strong foundations and everything else will build on top of that. That's all about data engineering. If you found this video helpful, make sure to subscribe for more videos like this. Thank you.